And welcome back. So we're going to pick up the discussion with this next subsection 15, which is colon cancer prevention. And this is, research I've been following since the early 1980s in the journal articles very closely. So I've assembled this section of this program to try to give you an update on what really has emerged over the last 20 or 30 years as to be the most important factors that increase colon cancer risk. And it's important because colon cancer in this part of the world is the second leading cause of cancer death in North America. Usually occurs after the age of 50, but as you're going to see, it's starting to occur even earlier. Some authorities are suggesting now that colon cancer screening begin around age 45 because there's been an increase in recent years. And so there are certain parts of the world where colon cancer is almost non-existent. And in those countries, they have different lifestyle and dietary behaviors. And when those individuals then, leave their country and migrate to somewhere in the Western world, very often within one generation, colon cancer risk increases to the same levels of what that you see in North America and much of the Western developed world. So the research I'm going to show you strongly implicates the fact that diet and lifestyle is the primary driving factors that increase colon cancer risk. And because it's the second leading cause of cancer death, when you combine statistics for men and women, it's something that we should have an in-depth knowledge of. So I'm going to try to share with you the latest sort of research that we've seen in these fields in the last 10 years or so. So with colon cancer, it often doesn't cause any symptoms until it reaches a more advanced stage. And when symptoms do occur, it depends really on the site in the colon where the lesions are. Generally speaking, the nearer the lesion is to the anus, the more bowel symptoms there will likely to be, like bleeding and so on. But other sort of indicators that colon cancer might be there can include a change in bowel habits, either frequency of bowel habits, constipation or diarrhea, but also quality changes or consistency changes of the stools. And of course, blood in the stools demands that you have an assessment immediately. And sometimes mucus in the stools can be an indicator, and the feeling of incomplete defecation, that sensation that pressure still remains there, or a reduction in the diameter of the feces can be an indicator. And of course, bowel obstruction, that's a more rare situation. Thus, if people 50 years old and older, they're saying now even at 45 years and older, that periodic screening with fecal occult blood testing and colonoscopy really is the gold standard, should be done. Remember that with colonoscopy, if they find polyps, they can actually remove them. So it becomes sort of a preventive procedure. It's not just an early detection, it's actually a procedure to remove what could be precancerous lesions, because it's these polyps or these adenomas that eventually can progress to become colon cancer, which is adenocarcinoma. So by removing those in their early development, you're preventing cancer. You're not just looking for existing cancer. You're looking for signs of lesions, polyps that may one day turn into colon cancer. So it has a therapeutic application, not just early detection. So that'll take us to our next slide. So this shows you the colon cancer increases that occur after the age of 50. And so you can see men in black and yellow, women sort of in yellow gold here. And you see that after age 50, the incidence really climbs for those next few decades. And then, of course, as there's fewer people alive, it drops a little. They die of other things once they get into their 80s. Alzheimer's and other things can happen. But this is a significant rise, and it's not normal. In developed countries, these rates are much higher, as you're going to see shortly. And so only about 5%, maybe 10% maximum of colorectal cancer is tied to inheriting genes that really strongly predispose a person to colon cancer. So up to 90% of colon cancer cases are thought to be produced by dietary and lifestyle influences on the colonic epithelium, as we're going to see. But let's understand colorectal cancer and genetics first, so you understand a couple of the things that can increase risk. A small percentage of colon cancer cases are attributed to inherited genes that greatly increase the risk of the disease. About 2 to 5% of all colon cancers arise in the setting of well-defined inherited syndromes, including Lynch syndrome and familial adenomatous polyposis, or FAP, and other sort of polyposis type conditions that are even a little less common than that. But FAP, or familial adenomatous polyposis, is one that crops up. And it's just that the person tends to have this tremendous genetic predisposition to producing hundreds of polyps, known as adenomatous colon polyps. And every 6 months they have to have those polyps removed. Otherwise, eventually one of them will degenerate into a malignancy and they'll have colon cancer. Now, the reason why this develops is because of a germline defect in the APC tumor suppressor gene. So you're going to see that the tumor suppressor gene interacts with what's called the Wnt signaling pathway and the beta-catenin transcription factor. And when that system is upregulated all the time, and the APC tumor suppressor gene can't downregulate it, then it causes the cells to divide at a faster rate and upregulates other genes that tend to create cancerous changes. So this particular inherited mutation runs in families. That's why it's called familial adenomatous polyposis. And polyps are also known as these adenomatous polyps. Now, with Lynch syndrome, it's a little bit different. Lynch syndrome is not just linked to colon cancer, but this sort of broad-based genetic defect also increases the risk of many other cancers that you see here as well: endometrial cancer, ovarian, stomach, small intestine, hepatobiliary, upper urinary tract, brain, and skin. So in Lynch syndrome, what happens is that when the DNA is dividing during cell division, in mitosis, when the DNA template sort of unravels, and then you have to get the complementary base pairs to line up for the new cells that are forming, that sometimes the cell inserts the wrong base pair. And there are sort of these little DNA repair systems that can go out and find the mismatched bases and actually take the wrong one out and put the right one in. And so this is sort of the DNA, this defect is in the DNA mismatch repair system. And that mismatch repair system is necessary for maintaining genomic stability by correcting single base mismatches and insertion deletion loops that form during DNA replication. So the idea is that it finds these mistakes that are made and it corrects it before those mistakes become permanent. Because if you have permanent mutations that are put into proto-oncogenes, that will get the cell dividing at a faster rate and set into motion all the things that create cancer potential. So that's what Lynch syndrome is about, and I would hope for you to hang on to that information, because that's a very important risk factor for a number of cancers. But what the overall evidence shows is that diet and lifestyle are the primary drivers of colon cancer. The evidence shows, as I will illustrate shortly, that 70 to 90% of all these cases of colon cancer are avoidable through diet and lifestyle. So the main factors that seem to be at the root of what's driving colon cancer would be a high animal fat diet, with the exception of fish. Eating fish would be a good idea. And getting enough fiber helps to reduce cancer. We're going to see that. And getting enough calcium, 1,000 to 1,500 milligrams a day. Having enough vitamin D, a blood level above 75 nanomoles per liter. I'll show you these numbers later. Possibly antioxidant supplementation with vitamin C to block nitrosation reactions. The role of folic acid and B12 are important for DNA stability and methylation. Alcohol increases colon cancer significantly. Selenium may play a role in preventing colon cancer. There's an ideal blood level of selenium that's strongly associated with decreased risk of polyps and colon cancer. Eating more cruciferous vegetables, avoiding nitrates and nitrites that are added to foods, as well as charred foods and smoked foods and foods that are cooked at very high temperatures. And also cigarette smoking increases risk of colon cancer, as does obesity, especially abdominal obesity. So I'm going to break all of these down and we'll discuss each one of them. So the evidence to suggest that colorectal cancer is strongly related to dietary and lifestyle factors was first identified back in 1981 by Dole and Pito in the Journal of the National Cancer Institute, showing that 35% of all cancers seem to be preventable through better dietary behaviors. But then by TissueCyte, they showed that 90% of colorectal cancer was preventable by better diet and lifestyle. So the kind of studies they did, they looked at worldwide studies, looking at the incidence of cancers in different countries, then migration studies, what happens to certain populations when they migrate to another country and they adopt new dietary and lifestyle behaviors there, what happens to cancer rates. They look at case control studies. So they sort of compile all the evidence together, all the epidemiological evidence. And they're saying, 90% is avoidable through better dietary behaviors. Then Dr. Walter Willett of Harvard University in 1996 published this same data that he sort of put that data together in 1994, but it got published in 1996. In the Journal of the National Cancer Institute again, showing that 70% of all colorectal cancer was preventable through improved dietary measures. But when you factor in alcohol and obesity and lack of exercise and exposure to other environmental carcinogens, he actually would agree that 90% of all colorectal cancer is preventable. So let's break down these sort of risk factors that I'm talking about. We'll start with this high animal fat diet. I'll show you some of the research that's surfaced, in recent years. This was a nice summary looking at the association between dietary fat intake and colorectal adenoma in Korean adults. This is a great paper here in 2017 because it gives a historical view of the role of high-fat diets in colon cancer, and then it also explains that in South Korea, where there's been some affluence that's occurred in recent years, there's been a major shift in dietary practices. As people have more money, they spend more. They have more money for meat products and higher animal products. And as they made that shift culturally in terms of integrating those new dietary measures, that colorectal cancer has really started to spike as a result of that. So here's how they build the case. They say that over the years, many epidemiological studies have suggested that among various environmental factors, diet plays a key role in the risk of colorectal cancer. In the Health Professionals Follow-Up Study, this is a giant cohort of following health practitioners in the United States. The scientific director of that study is Edward Giovannucci. I'm very familiar with his work. But he was able to show that following all these health professionals, the ones eating a lot of red meat have a much higher risk of developing colon cancer compared to other people with practitioners with different dietary behaviors that don't do that. A pooled analysis of case control studies suggested that high fiber intake was inversely associated with risk of colorectal cancer, and we'll spend a lot of time talking about dietary fiber in the next portion of this. Some case control studies have shown that high saturated fatty acid intake is associated with increased risk of colorectal cancer or adenoma, so either polyps or full-blown colon cancer. In addition, animal fat intake showed a positive association with risk of colorectal cancer. There are a number of case control studies that have suggested that. Now, recently, the incidence of colorectal cancer has sharply increased in South Korea. The trend may be because of the transition of risk factors as well as the effect of colorectal cancer screening. So they're saying eating more high-fat meat products, but also we're introducing more colon cancer screening, so we're going to catch more cancers as well. The major change in dietary patterns is a large increase in the consumption of animal food products and a fall in total cereal intake. Most colorectal cancers arise from benign adenomas. So those polyps are the first step. That's why colonoscopy, which can remove those adenomas, is so important for prevention. But they go on to develop over several years through an adenoma carcinoma sequence. Previous studies showed a positive association between total fat intake and risk of colon cancer, and this was usually attributable to fat from animal sources or saturated fatty acids in particular. Some case control studies have suggested that animal fat intake shows a positive association with risk of colorectal cancer. Moreover, other studies have shown that high saturated fatty acid intake is associated with increased risk of colorectal cancer or adenoma. Our study, the South Korean study, analyzed both animal fat and saturated fat intake. And what they showed was only saturated fatty acid intake was positively associated with colorectal adenoma, in part consistent with the results of prior studies. An early animal study demonstrated that the tumor-promoting effects of dietary fat might be partly independent of its caloric density. In other words, fat itself, over and above calories, has its own unique way of promoting cancer to develop. With respect to saturated fats, a previous study suggested that diglycerides containing saturated fatty chains induce mitogenesis of adenomas. It means it gets the polyps to start replicating, and some carcinomas in the colon. It stimulates their cell division rate and proliferation and may enhance the invasive capacity of carcinomas. Another experimental study demonstrated that saturated fatty acids, essential for liposaccharide and toll-like receptor 4 activation. So these are sort of receptors that get identified, that drive these cancerous pathways. Induces nuclear factor kappa beta activation, which is a transcription factor that increases cell division, as well as expression of cyclooxygenase 2, which promotes the types of prostaglandins that get cells dividing very, very quickly. So these types of biomarkers are very much related to increased risk of cancer, and they are also major inflammatory markers. And where there's inflammation, there's always a greater risk of cancer. Our study results suggested that high saturated fatty intake was positively associated with colorectal adenoma, but there was no significant association between monounsaturated fats or polyunsaturated fats with colorectal adenoma. In other words, they're specifically saturated fatty acids, and they usually come from high-fat animal products. Recent studies have shown variable effects on specific subtypes of polyunsaturated fats, such as icosapentaenoic acid on colorectal cancer. It suggested that by substituting food, saturated fatty foods, really, for high medium-chain fatty acids, arachidonic acid or icosapentaenoic acid-rich food may contribute to reduced risk of colorectal cancer. Also, increased consumption of icosapentaenoic acid and docosahexaenoic acid, this is eating more fish as a rule, was associated with reduced risk of colorectal cancer, likely because those omega-3 fats make prostaglandin series 3, which slow down the rate of cell division, and they reduce inflammation. So this takes us now into the story of bile acids. So I have mentioned in this program that when you eat more fat, particularly saturated fat, you tend to secrete more bile into the intestinal tract. And then the bacteria in the large intestine can convert some of that bile into secondary sterols, which can increase colorectal cancer outcomes by creating changes that lead to colon cancer. So the more of this fat you eat, the more bile acids you secrete, the higher tends to be the concentration of secondary sterols that reach the large bowel. So that's what this is going to talk about. This was a nice 2016 review article on bile acids, a potential inducer of colon cancer stem cells. So in what we're seeing here is that lithocholic acid and deoxycholic acid, these are secondary sterols now, formed from the bacterial transformation of bile acids made in the liver and secreted into the gut. That those secondary sterols are risk factors for colorectal cancer. That's been very well established, actually. Epidemiological studies have revealed that the incidence of colorectal cancer among populations migrating from low incidence to high incidence countries changes rapidly. Within one generation, the incidence of colorectal cancer reached its highest level in people migrating from Japan to Hawaii. This has been thought to be largely due to changes in their dietary behaviors. This inference comes from the observation that large increases in both meat and fat in rich diet are associated with a rise in colorectal cancer. Additionally, populations with high incidence of colon cancer also show an increase in fecal concentrations of bile acids. The more fat you eat, the more bile acid you secrete, the more of it reaches the large intestine, and a lot of it becomes secondary sterols. These observations suggest that increased exposure of colonic lumen to high levels of bile acids may play a role in the natural course of development of colorectal cancer, and certain bile acids have been categorized as potential tumor-promoting agents, particularly of colon cancer. higher levels of secondary bile acids in the feces and increased incidence of colorectal cancer were observed in patients that consumed high-fat, low-fiber diets. So it always comes back to this. Several epidemiological studies have also revealed an association between bile acids and colorectal cancer. The presence of colorectal cancer has been associated with higher fecal lithocholic acid, deoxycholic acid ratio, and with elevated fecal secondary bile acid levels. Although the precise mechanism by which bile acids induce colon carcinogenesis is poorly understood, DCA and chenodeoxycholic acid mediated genotoxicity in normal human colonic epithelial cells as well as in tumor cells has been found to be due to DNA oxidative damage. So that's with deoxycholic acid and chenodeoxycholic acid, you start to see this genotoxic effect, often due to oxidative damage to the DNA of the intestinal epithelial cell. So the conclusion is that taken together, our current data show that certain secondary bile acids, specifically deoxycholic acid and lithocholic acid, which are known for their co-carcinogenic activity, are able to induce these are colon stem cells, colon stem cell cancers in colonic epithelial cells. So that's what CSC stands for. These are colon stem cell cancers. This is evidenced by the observation that deoxycholic acid and lithocholic acid are not only able to stimulate the expression of several surface epitopes, right? So these epitopes are like receptors on the cell surface. It's part of the antigen recognized by antibodies and immune cells for binding purposes. So this is of colon colon stem cell cancer cells, but also the markers of EMT. So the EMT is the epithelial mesenchymal transition, is a process by which epithelial cells lose their cell polarity and their cell-to-cell adhesion, and they gain migratory and invasive properties to become mesenchymal stem cells. So EMT is seen in the initiation of metastasis and in cancer progression. There's some theories out there that it's primarily stem cells in the different tissues that actually give rise to cancer. We're going to see this in the adjunctive nutritional management of cancer subject, which occurs in course 106 on this platform. So that's coming up in like the next subject matter. But understand that as you take normal epithelial cells, the first step in cancer is often a change on the cell surface of certain receptors or markers, these epitopes, and also you change the nature of these cells in a way that makes them more likely to invade other tissue and metastasize. So these increases of these epitopes in the EMT system are associated with increased spheroid formation, a rise in the expression of multi-drug resistance transporter genes. So what is that? If once you have a cancer cell form and you want to try to kill that cancer cell with chemo drugs, if it upregulates its multiple drug resistance transporter genes, it pumps the chemo out of the cell back into the extracellular space to protect itself. So it's a way for the cancer cell to defend itself against chemo drugs. So with this type of transformation to this type of cancer cell that the colon cancer cells become, they tend to defend against a whole lot of chemo drugs that are being thrown at them. Deoxycholic acid and lithocholic acid induction of colon carcinogenesis is found to be regulated by the M3R. This is the muscarinic receptor 3, which I will show you, which then in turn upregulates the matrix metalloproteinases and makes the cell very invasive. Let me show you what I'm talking about. So remember that these secondary sterols tend to upregulate the system I'm about to show you. So when you eat a lot of fat, especially saturated fatty foods from animal products, you tend to get more secondary sterols, deoxycholic acid and lithocholic acid, and then they activate the M3R receptor. And the M3R receptor, once it's activated, through P38 alpha stimulates the nucleus of the cell to upregulate the matrix metalloproteinases. These are enzymes that then drill a hole through the extracellular matrix so the cancer cell can invade adjacent tissue. And that's how the cancer cell can spread from the colon to the bladder or to an adjacent tissue. By upregulating its matrix metalloprotein, it makes it very invasive. And bile acids tend to stimulate that M3R receptor, which then sets into motion the signal transduction pathways, including through the epidermal growth factor receptor system that also makes this highly invasive. So in the 2014 update on bile acids and colorectal cancer in the World Journal Surgical and Oncology, bile acids, they say bile acids were first proposed as carcinogens in 1939. Since then, accumulated evidence has linked exposure of cells of the gastrointestinal tract to repeated high physiological levels of bile acids as an important risk factor for gastrointestinal cancers. High exposure to bile acids may occur in a number of settings, but most importantly, it's prevalent among individuals who have a high dietary fat intake. A rapid effect on cells of high bile acid exposure is the generation of reactive oxygen species and reactive nitrogen species, disruption of the cell membrane and mitochondria, induction of DNA change, mutation and apoptosis, and development of reduced apoptosis capability upon chronic exposure. So once the cancer cell forms, it can't actually induce apoptosis and kill itself. So I think that's a pretty big chunk to digest right there. So the lesson number one is that there's tremendous evidence to suggest, and there's pretty much universal agreement on this, that a high animal fat diet with long-chain fatty acids tends to directly encourage inflammation and cancer development, and secondly, by increasing bile acid secretion and creating more secondary sterols in the large intestine, that you actually make the high-fat diet even worse for the individual. And we think this is why people who are vegans and vegetarians, in most places in the world, that they have a much lower incidence of colorectal cancer. We think that the high plant-based diet with fiber and less saturated fat is helping to protect them. So let's leave it there, and we'll come back and we'll pick it up after the break with the story around dietary fiber.